So it's really important to be able to draw the triangle. So this one looks like this in the third quadrant. Cotangent is, well, tangent, here's u. U is always made with the reference, I'm sorry, with the x-axis. That's the reference angle. U, the cotangent of u, tangent is opposite over adjacent, so cotangent's reciprocal of that. So it's 4/1. But because you're in the third quadrant, they're both negative. And then the hypotenuse here is this squared plus this squared square rooted, so it's the square root of 17. It's kind of a standard thing to be able to do here. The next step here is to find the half angle. These are u divided by 2. And for sine, let me snip this in. Yet another formula. There's a half angle formula for each sine, cosine, and tangent. So here it is. So notice, like in your problem, you're finding sine of u over 2, and notice that it's 1 minus cosine u over there. Sometimes there's confusion about that, but u is the angle, so we just need cosine of u. Basically, cosine of u is minus 4 over the square root of 17. We can or cannot, we could rationalize it. I'm not sure if it matters here. So you just take this part right here and you substitute it into here for the whole thing. So the answer is, and then we'll decide whether it's plus or minus in a moment, but the answer is 1 minus 4 over square root of 17 all over 2. Do you know how specific your instructor wants you to be on a test or quiz for simplifying this, Niko?
I don't know. I think, Jamie, do you know?
Yeah, do you have any insight, Jamie?
It's just supposed to be like fully simplified.
So I hear the language on that, and like what that means is making a common denominator, rationalizing, and a few other things like that. But it from here, it's a lot of steps. WebAssign will generally just accept this. So I mean, well, let's carry that through just a little bit here. So if you rationalize this one on the right here, it's 4 square root 17 over 17. 1/1 becomes 17 over 17. And you're still a square root of that all over 2 plus. So it becomes 17 plus 4 square root 17 over this 2 comes up here 34, like that. I would consider that fully simplified. Okay, so now to the issue of whether it's positive or negative. So the way that I would do it is if your u is in the third quadrant, which it is here, u is in Q3, and that means it's somewhere between 180 to 270. U over 2 is going to be, you cut these numbers in half. So 90 to 135, that puts you in quadrant 2. Is sine in quadrant 2 positive or negative? And it's positive. So that's how you choose. You look at where the half angle fits, which quadrant it is. You remember that all students take calculus, and that tells you the sign after you do this part. There are 3 total half angle formulas. So the cosine one is really similar. So the cosine here is 1 plus instead of 1 minus. So I think all that does is change the sign inside here. So it'll be root 17 minus 4 root 17 all over 34. And then it's kind of the same deal here. So you're in the second quadrant, so cosine is negative there. tangent is slightly different. Again, more stuff to remember here. Tangent is 1 minus and then 1 plus. So it's going to be 1 minus, what did I get it to be? Minus 4 squared, 17 over 1 plus minus 4 over square root 17 square rooted. So this is like 17 plus 4 square root 17 over 17 all over 17 minus 4 square root 17 over 17 square rooted. You can see that the bottoms cancel. And I don't really, my opinion, which is my opinion, it like this isn't really like all that simplified. It just like looks nicer. The second quadrant tangent is negative. So notice, Niko, just to summarize, like once you draw the triangle and figure out the sides, and if you know the formula, you just substitute in. All right, Jamie, you sent over some problems, some WebAssign also. Let me do this product to sum problem first, I guess. The looks like Niko has one similar. But before I do, Niko, any follow-up to this? Anything on here that you need me to clarify?
No, I think.
Okay.
Got it, yeah.
All right. Sum to product formula. So we actually need that sum to product. And let me go find it. So there are 4 flavors of this sum to product formula. I guess I should send you guys the link to that reference sheet I'm using. I find it really, really helpful. So I refer to this over and over again. So this one is, there's kind of like, you should probably factor out a 9 first. So it's 9 sine 11 pi over 12 minus sine 7 pi over 12. But once you have this, you just recognize the form. It's sine alpha, sine beta. These are your alphas and these are your beta. And notice it becomes 2 cosine alpha plus beta. So 11 pi over 12 plus 7 pi over 12. Sine, and then you subtract 11 pi over 12 minus 7 pi over 12. And divide by 2. Sorry, I didn't get that. Divide by 2. And then this 9 comes down. So this 9's on the outside. So it's 2 cosine 18 pi over 12 was that 3. So this becomes 3 pi over 4. It should reduce to something nice, something that you know how to do. This one's 4 pi over 12, so pi over 6. And then there's a 9 on the outside. So let's see here, cosine 3 pi over 4. You know, you go to your unit circle, that's over there. That's square root 2 over 2 times 2 times sine pi over 6. That's 1/2. And then you got a 9 out front here. So looks like those cancel, but then the 2 comes down. So it's like 9 root 2 over 2. Jamie, is that something you could probably do on your own, or how?
Probably.
So you got to know
I don't know
these.
how, but I got a root 6 in there. When I did it, I don't know if I just like mix something up.
Did you reduce them
But-
to the 3 pi over 4 and the pi over 6?
Yeah.
I mean,
Oh, I know what I did. I multiplied by square root of 3 over 2 instead of 1/2.
So 1/2. Yeah, that'll do it. So on like an exam, you know, maybe you'd get deducted a small amount on that, but on WebAssign, it doesn't take it at all.
Yeah.
So there's 4 of these. You got to know all 4, I guess. I mean, there's patterns in here. I think you could try to remember them, but there's a lot here, like try to learn early, remember early
Mhm.
what you're working on. So Niko, I'm gonna grab question, I guess 11, because 10 is kind of like 11. I'm gonna grab, and the this time it's product to sum, not sum to product. It's like going backwards on this. It says use product to sum formulas to write the product as a sum or difference. So if I go back to that reference sheet, once you have the formulas, like once you know them, you just identify the type. So let me show you this. And then I'll make just a comment here on this. So the way this formula sheet is written is if you have a plus, it becomes, oops, I'm using the wrong ones here. That's not it. It's product. We're doing product to sum, sorry. Go get those. All right, product to sum. So you got to identify your alpha and your beta, or if you prefer like big A and big B. And then it's just a matter of patterning it. Like, okay, we're using the first one here. So the 11 just hangs around, but it becomes 1/2 cosine, and then it's alpha minus beta. So you just do it in the order you see it here. That's 3 alpha minus 4 alpha minus cosine 3 alpha plus 4 alpha. So it looks bad, but let's see if we can make anything of this. So it's 11 over 2, and then it's cosine minus alpha minus cosine 7 alpha. One thing that you might be expected to do is remember that cosine of minus alpha is just cosine alpha because it's an even function. So it could be that the final answer is supposed to be cosine alpha minus cosine 7 alpha. So yeah, another 4 formulas. I mean, they're similar, so there's ways to remember them if they're not. For number 10, Niko, I mean, it's the same thing, except you would end up getting a numerical answer for that. Do you want to try that one on your own, or do you want us to work through it together, Niko?
Yeah, but on number 11, I put it in and it says it's wrong.
Well, that's awful. Jamie, did you already do number 11 for this one?
Yeah.
What did your answer look like? Because the only thing that would have changed is this 11 here.
Mine was 9 over 2 times cosine alpha minus cosine 7 alpha.
Something like this.
Yeah, that's what it was.
Yeah. So I mean, check your sign. Check just parentheses, Niko. Check you got big parentheses. Jamie, it sounds like you had a 9 here instead of 11.
Yeah.
Yeah, I forgot the parentheses.
Okay. All right, great. So this is exactly the same problem here, Niko, except instead of symbolic, you've actually got angles, so you have to evaluate. Do you have time to try that now, Niko, or do you want me to work through it? Okay.
I can try.
All right. So Jamie, let me go look at what you sent next. You said you had some book problems. Are any of the book problems related to stuff we've been doing?
Not really. I mean, I've one off a test that I wanted to look at.
Okay.
It's like a verifying problem that I struggled with.
Okay. Yeah, we can do that.
Niko, the same one.
Was it that big one? That big one?
Yeah.
Yeah, that was horrible.
Okay. Why don't you get that over to me? Snippet, we'll take a look. But then we can also talk about this. This one's just quite awful.
Yeah.
So like I'm going to show you this, but like keep in mind there are many calculators that will like perform all the steps to like reduce this because it's pretty long. I mean, if you remember, like there were these problems where you were given all the zeros and then you had to find like the seventh order polynomial or
Oh,
like
God.
binomial
Yeah.
expansion theorem. I mean, that's essentially what's happening here. It's quite bad. So we're going to use these reduction formulas, but like sine to the sixth
Mm.
is sine cubed x squared. So that's one way to look at it. Another way to look at it is sine squared x cubed.
Mhm.
And I think this is the preferred way to look at it. So, and then we'll see. Maybe maybe we'll have missed something here. But there are three double angle formulas that you need to know when you're doing this. So the notice that this this middle one kind of comes in three flavors, three versions here, and it's got a sine squared in it here. So cosine of 2x equals 1 minus 2 sine squared x. So in short, sine squared x equals 1 minus cosine 2x, all divided by 2. And this right here, we can replace in here.
Okay.
Okay. Now, like that sounds good. It's like, oh, okay. Well, now we can do something. It's 1 minus cosine 2x over 2 all to the power of 3. So that means you got to cube the top
Oh.
and the bottom. Okay, you cube the bottom. So it's 1/8, but then it's 1 minus cosine 2x times 1 minus cosine 2x
Oh,
times 1
God.
minus cosine 2x. Yeah. And what happens is you're going to have to use the reduction formula again. So we'll foil this. You'll see it's, I mean, it's bad, but it's, you know, you guys are good math students. You can probably do this pretty quickly, pick it up pretty quickly. So 1 minus 2 cosine 2x plus cosine squared 2x. So that's the first foil. Then you got to do it again here.
Mm. Oh, my.
Yeah, so you got 1 minus 2 cosine 2x plus cosine squared 2x, multiplying each of these by 1. Then you multiply by this and you look for things that might match. This would give you a minus 1 cosine 2x plus 2 cosine squared 2x minus cosine cubed 2x. Now, I guess in full disclosure, I'm pretty sure this is the right approach. There might be another technique that I'm not seeing because it's a pretty like specific trigonometry problem that never gets done after this course. But
Mhm.
notice like this is fine, but now we need to use that formula again for this
Mhm.
one. And for here, we're gonna have to break this up to like cosine squared 2x times cosine 2x.
Mhm.
Like that, and do the same thing. We're gonna have to break this one up.
We'll just keep going.
Yes, yes, and I'm happy to continue, but let me
That's
yeah,
okay.
let me suggest let me just type this in and see if I can actually get the answer. But don't forget the 5 out in front. That's now yours,
Okay.
Niko. Maybe cosine instead of a
Sine. It's just
sine. I
sine.
mean, and it's the same idea. So here is Jamie, the like they've done a little factor, they've factored out some numbers, but this is what it ends up looking like when it's all done. Believe it or not. So I think there's a way to do this that's faster than what I just did, but I'm not sure. You might want to check with your instructor since they're doing this more than I am.
Mhm. Would it be easier to do one to like the fourth power? Like significantly easier?
I mean, it's just a repetition. Like, no. I mean, so no, not really, because
Got it.
it's just essentially the same. Like, yeah. I mean, It's just the same, just a lot of this, so.
Okay.
Niko, how did you do on this problem back up here that I'd sort of left off at? Did you get a chance to work through it?
I got to the one part and then I just have a question. So I got the second part was like minus sine of negative pi over 2. And so does that be is it just 1/2? Like it's just negative 1/2 because it's what 3
Yeah,
right? Or,
that sounds right. Let me, but
Yeah.
did you use this one down here? Hopefully.
yeah, I use the bottom one.
Okay, let me just write out here. So it's 5/2 sine. Now pi over 3 is really 2 pi over 6. So when you add them together, you get 7 pi over 6.
Yes.
And then when you subtract them, you get, like you said, negative pi over 2.
Yes.
So the sign of negative pi over 2 on the unit circle is down here.
Mhm.
So to me, that's -1. And then with that, it makes it
Just
+1. Yeah.
okay. Okay.
Then 7 pi over 6 is -1/2, I believe. So 5 over 4, maybe.
Wait, I think I did something wrong. 7 pi over 6.
So like 7 pi
Isn't
over
that
6.
negative 1/2?
Yes.
Yeah, okay, exactly. Okay.
And then,
Okay.
and then,
Plus 1.
yeah, this is, so I get 1/2 times 5 halves. Because there's a 5 to start, and then the formula has a 1/2 in it.
Okay. It says it's wrong, which I don't understand. I feel like I've done everything.
Cosine, sine, we add them.
Oh, it says do not simplify.
Oh,
I
there
also
you go.
leave it as
I guess leave it as is this what you entered, Jamie? Kind of a line like this?
For number 10, let me check.
Yeah, number 10.
I have it in like when it's still in the plus form. So like 2 times sine of pi over 3 plus 5 pi over 6 minus sine of pi over 3 minus 5 pi over 6.
also the first part. Okay.
That's-
Did you leave it as 5 times 1/2 or whatever your number was, or did you make it 5 halves?
You can make it the halves. Mine was 4, so I just made it 2.
Okay.
All right, I've got that exam question up. Now, have you guys looked to see like if this question was in your textbook? Maybe type it in online to see, like I mentioned this before, maybe your instructor's grabbing content from somewhere and get a feel for that. You may find that that's potentially useful. So Jamie, any idea how you might start this now that you've done it again?
I know you probably have to like factor it and make it like cosecant to the 6x minus cosecant to the 4x times the other 2. But I don't know where to go from there.
Okay, so like I see that these are the same, and like you said, there's matching numbers here. So at a minimum, let's just try this. I thought we did one kind of like this. Maybe it wasn't as big in terms of the exponent, but something like this. And then you can factor out a cosecant. So you can factor out a cosecant to the 4th x from both of these. And one of the things I see that I mean, I don't know if you would be able to detect, but this is what you're trying to do is you see there's 5 there. Well, now you got 5 here.
Oh,
So that's cosecant 5x cotangent 1x. And then maybe this gets us to a cotangent squared. Which I think it does.
Yeah, it does. Oh, that makes sense.
And then, okay, you combine them to get that. We've talked at times about SAT, ACT questions. This is like that where you need to look at the answer as you're working through it to like know if you're getting closer.
Okay. Question.
Yep.
Is there a good way to like recognize to do that? Because I guess that's what I'm struggling with. Because that makes sense.
Yeah, I hate saying it this way. They're really, it's like, have you ever seen problems where they ask you to find the pattern? Like what's the next number in the sequence? It's just your ability to like detect these things. It's not really a math skill. It's just
Got it.
seeing stuff. I mean, doing more problems would help, but you have
Mhm.
limited time. You don't know which ones to practice. And
Yeah.
if you saw this again, you would know how to do it.
Yeah.
But yeah, I mean, I don't, how much time do you spend on a question like this before you move on?
Like a couple minutes and then come back to it later.
You're on the right track because you wrote the same first line that I did, and then what did you cross out? Do you remember? Or is that on the other page? I can't see it on mine.
What do you mean?
Well, so what I'm looking at on your piece of paper is there's some stuff maybe in the background. I don't know if that's on the page.
Oh,
before.
that's like stuff I was trying earlier that I erased because it wasn't working out.
So here's a technique that you may find useful in the future. Is like, let's just say all of this was wrong, rather
Mhm.
than erasing, which takes a lot of time. You can actually just strike through like this.
Mhm.
And sometimes instructors will see, oh, he actually did know it. Did know it, and they'll.
Oh yeah.
But if you erase, it's gone forever. So it's kind of like hedging your bet that maybe you were right. It's also
Mhm.
faster to just cross through than to erase.
Got it.
Nico, was yours identical to this on the exam?
Yeah.
Okay.
Exact same thing.
All right. You guys need to sit closer.
Mhm.
I will.
All right. So any other stuff specifically from WebAssign you want us to go through, or maybe some more book problems, concepts, Nico? You sometimes have sent some of those over.
Can we go over what's it called? The double angle formulas. Can we just go over those concepts?
Sure. So just you gotta just double confirm here this is what you want to work on, because I'm going to add in a little twist here. So here's the double angle formulas. There's also the half angle formulas that we kind of were looking at earlier. These somewhat work together. You can kind of see that if you study real hard, like the one we used for reducing that sixth order sine. They just solve it for sine squared. That's what we did, and then they take a square root. But the problem you're going to see in an exam is they'll tell you that the cotangent of A is 4/3, and it's pi less than A less than 3 pi over 2. And then they'll tell you that the I'll just make this just for my sanity, I make this easy. It's the sine of B is 8/17, but you're in quadrant 2. And the style of problem here, if you haven't seen this already, is you have to draw both triangles. So this is A in the third quadrant, and then cotangent. Tangent would be 4/3, but cotangent is 3/4. But they're both negative because you're in the third quadrant, and then this is a 5. Somehow this would tell you you're in quadrant 2, like it might tell you that tangent is less than 0. That would be one way to tell you this. But in quadrant 2, the triangle looks like this. That's B. That's 8. That's 17. This is -15. So once you get the triangles, and I've chosen nice ones, but you may not get nice ones. They can literally ask you any combination of these things. They could ask you like, what is cosine 2A plus sine A divided by 2, or B divided by 2. And you have to go back to these formulas to be able to do them. So is that the kind of question you're thinking of, Nico, or is it?
Yeah.
Okay.
Just kind of use the triangles. So.
Yeah, so like when you get cosine 2 theta, you have to choose one of these. And they're all kind of the same. Like, I don't think one is easier than another. But I like the cosine. I like the cosine squared a minus sine squared a for this one. So I go back here and use it. So what some students do is they actually write out like sine, cosine, and tangent. I think that's slow. I would just write them out as I needed them. So that's minus 4/5 squared minus, and then sine a is minus 3/5 squared. So was that 16 over 25? So over minus 9 over 25. So we got 7 over 25 for that. And then sine of this b over 2. We got to go get a formula for that. That's this plus or minus square root 1 minus cosine b over 2. Okay, so we'll deal with the plus or minus in a moment. Cosine b is minus 15 over 17. So it's 1 minus 15 over 17 over 2. Okay, so this is really 17 over 17. So this is the square root of 32 over 17 over 2, which is 34. So this becomes the square root of 16 over the square root of 17, 4 over the square root of 17. Then you got to rationalize 4 square root 17 over 17. And still this plus or minus. At some point we should deal with that. And we're going to add that to our previous answer over here. So notice that B is in the second quadrant. It's somewhere between 90 and 180. So when you take half of that, that's 45 to 90. And in the first quadrant, that's Q1. Everything is positive. Please don't guess. You guys have the ability to figure this out. It's not worth it. You can just do the quick division and see. So your final answer is you add them up like that. Now, normally they just give you one of these. They'll give you 2 of these triangles and say, what is cosine 2a? That's part A. What is sine b over 2? Or what is tangent 2a or cosine b over 2, a over 2? It doesn't really matter. There, if you have the formulas, it all goes back to sine, cosine, and tangent, or just sine and cosine in these cases. Like, so the formulas are really important here. All right. Niko, is there any follow-up to that? Anything else?
No, I think I got it. I just gotta kind of remember some of the double angles and stuff.
Yes. Yes. All right. So Jamie, what?
I got a worksheet she gave us. There's a problem I want to send from it.
Okay.
Can we go over 2 and 3 from what I just sent over?
Okay, got it here. Which side should we work on, Jamie?
I would say the left.
Okay, what did you try first, if anything?
I would probably. I would want to like try to switch over like sines and cosines maybe.
Okay, I can see why you would do that, because like something might combine. So let's try that. 1 over cosine, sine over cosine. And then this is 1 over sine plus 1. So this, nothing really like stands out to me here. I would tell you to foil, I guess, because like you would get 1 minus sine on top, and then over here, you're gonna get 1 plus sine on top. You would probably, but let me just, I mean, like secant times cosecant. Does that give us anything? Well, let's just say secant theta, cosecant theta. Like if we just look ahead here, it's 1 over cosine times 1 over sine. Is that any better? Not sure. I'm not sure that's better either. Let's look a little further here. Minus tangent secant. That is tangent cosecant. I guess that's somewhat better. Okay, let's go with your approach here and retract what I said here. So this becomes on the left 1 minus sine theta over cosine theta. Excuse me. And then on the right here, you make this sine over sine, so it becomes 1 plus sine theta over sine theta. And then when you multiply the tops and you multiply the bottoms, you get 1 minus sine squared theta, because it's a minus b times a plus b. And on the bottom, you get sine theta, cosine theta, or cosine theta, sine theta, or it doesn't matter. What is 1 minus sine squared theta as an identity? Cosine squared theta. So that the top becomes this. And then the bottom remains 1 of the cosines from the top cancels with 1 on the bottom. Cosine over sine, which I guess you guys are expected to write out, is cotangent theta.
Oh, okay. That makes sense.
Now it's possible that foiling would have also led us down the same path, but I'm not sure until I try it out. That should give you some idea that you really do have to a little bit of guess and check here.
Yeah.
Niko, is there anything else you would like us to look at specifically? I don't want to take up all the time here, just doing this last problem with Jamie. If there's something you would like to work on.
I just have a question about that. Like, I'm still confused on that 3 sine 6x. I just don't know where to go from there. It was number 7 on that website.
Let me go back. Did you send it to me?
I think so. Yeah.
Let me go back and check.
It should be.
Oh, that one. Okay.
I just stuck.
So this one, yours is more specific. It does say to do it in terms of cosine. So let me try this another way here. So this is really sine squared x cubed. And then we can write this as 1 minus sine squared x. I'm sorry, 1 minus cosine squared x cubed. But I don't think it's going to help. No, that's definitely not gonna help. Okay, so we have to use one of those double angle formulas. I'm gonna grab them again.
Yeah, I should be on time. Case 4:30. That's scheduled before.
All right, so here are the double angle formulas, but then if you go to the page 3, they also give you the alternate form of the half angles, which I think is maybe more useful here to know. They already tell you what sine squared is. Sine squared is 1/2 1 minus cosine 2x cubed. So from here, let me just like it's 3 times 1/8 and then 1 minus cosine 2x cubed. Oops, sorry, this is the cubes in there. And then so if you understand up to here, this is 3/8, and then this part inside here that you're cubing, we did that earlier. Let me go. I mean, it's this 1 minus cosine x times itself. And let me go and grab it from earlier. So it's all of this, and then the 3/8 is out in front. So I was trying to explain earlier is that for this one right here, you have to use the same thing. You have to say, okay, well, cosine squared is really 1/2 1 plus cosine 2 theta. But this last one is cosine squared 2x times, that's an x, times cosine 2x. And then cosine squared 2x is really this 1/2 1 plus cosine 2x. And you have to continue. You have to like multiply. So it's minus 1/2 cosine 2x minus 1/2 cosine squared 2x. And then you have to do it again. Like you have to substitute in for this. And you have to, all these terms flow in. And I'm not being careful enough here, but that is like, this is the process. Like every time you get down to cosine squared, then you can finally like reduce it to a cosine of degree 1.
Okay.
And Jamie said like, well, is a 4th degree better or easier? I mean, it probably is. There's probably like one less term to deal with when you're doing it. But in terms of like your answer, let me like just snip in the final answer for this. 3 sine 6. The other thing is that these online calculators, they also combine them a bit better than we're doing here. Like we're gonna end up with 1 2 3 4 4. We're gonna end up with more terms, but they're combining them. All right, so Jamie, I think we can close out by doing this last verify problem. Number 3, is that the one?
Yep.
So when I look at this, the left side appears to be the choice to work on,
Yep.
and the right side is really simple. So maybe there's something here that's not bad. Whenever I see a 1 plus, I'm tempted to multiply by the conjugate. But I want to check, is 1 minus secant squared theta is that a half angle, or I'm sorry, a double angle? I gotta look. No, well, secant squared minus 1 is. So, do you remember if you tried anything here?
I was just gonna go with like getting a common denominator and just like going from
makes sense
there.
too. that makes
But-
sense too. So
okay,
that would
yeah.
be
Didn't know
tangent
if that-
theta. It doesn't immediately like get better, but it
Mhm.
it could. So let's take a look. That would be tangent squared theta plus 1 plus secant squared theta over 1 plus secant theta tangent theta. All right, so now we're gonna expand the top. So this that's squared. So that becomes 1 plus 2 secant squared theta plus secant to the 4th theta. Definitely don't like that, but
Wait, the secant on top is not going to be a 2 in there.
thank you. That was about to say that was not gonna be good. All right, so that's going the wrong way. So we got secant theta and then plus secant squared theta over 1 plus secant theta tangent theta. All right, so what I'm seeing here is that from the formula here is tangent squared theta is secant squared theta minus 1. So the numerator is secant squared theta minus 1 is to the tangent plus 1 plus 2 secant theta secant squared theta. So those cancel and you have 2 secant squared theta plus 2 secant theta
Mhm.
over this. Now, what I am seeing is that you can factor out a secant theta, which
Oh, yeah.
I don't know if that's going to help here, but so 2 secant theta, and then it leaves you a
You'll be able
secant
to
theta.
cancel out with the bottom, right?
Right, so that cancels out with that. Okay, and then you got this tangent theta. So secant is 2 times 1 over cosine theta. Tangent is sine theta over cosine theta, so the bottoms cancel. And 2 over sine theta is cosecant theta. So it did work out.
Oh, that makes sense.
All right, well, that does take us to the end of our lesson today, guys. I really appreciate you scheduling. I'll send you the notes here shortly, and I'll see you next time.
Thank you.
Have a great night. Bye now.
But